String theory brings together the two pillars of 20th century physics, quantum mechanics and Albert Einstein's theory of relativity, into a single framework that can describe all of the reality of physics. At its core, the theory is very simple. It suggests a particle isn't a point-like object, but an extended object, just like a string. It suggests that if we took any particle, electron, proton, quark, etc., and zoomed really close in on it with an extremely powerful microscope, what we would actually see is a string, vibrating in intricate ways that appear to us as particles. These vibrations determine the attributes of a particle, be it proton, electron, photon, quark, etc. A photon, for example, which is a particle representing a quantum of light, may be formed by a string of a specific length striking a specific note. In the same way, a quark could be formed by a string folded and vibrating at a different frequency, and so on. The different vibrations are also what create the forces. What's even crazier is that while we can move in three different ways, up and down, left and right, and back and forth, a string can move in 10 ways. Strings are one-dimensional themselves, like a line, but they can move through multiple dimensions, and how they move through those dimensions is thought to be what gives things in the universe their attributes. It's kind of like a guitar string. Strings on a guitar are one-dimensional, but they can vibrate through 3 dimensions, and how they vibrate determines the sound they make in the same way that in string theory, a string vibration can produce a photon, a quark, and other particles. String theory was first introduced as a model of strong interactions. It was found that this theory could describe specific cases of particle scattering observed in the strong interactions between hadrons, the subatomic particles like the proton and neutron. Scientists, however, started to shift their focus from string theory after they realized that another theory called quantum chromodynamics described the strong interaction much better. This theory suggests subatomic particles called gluons are the ones that bind quarks together to make more familiar subatomic particles, such as protons and neutrons. However, the string theory is still strong, and scientists use it to explain many things. The theory is one of the proposed methods for producing a theory of everything. Unlike the standard model of physics, which can explain everything except gravity, string theory can explain everything including gravity. The theory explains gravity the same way it explains other particles. A string can vibrate in a certain way that it can manifest itself as the hypothetical graviton, a quantum mechanical particle that carries the gravitational force. Scientists use this theory to try to answer fundamental questions about the universe, such as what happens inside a black hole, how did the Big Bang occur, what is dark energy, the mysterious force that accelerates the expansion of the universe, etc. However, it's extremely hard to prove its predictions with the current technology, and many researchers have doubts whether it will ever work. But other researchers are confident with the advancement of our technology, string theory will one day turn up results.